everyone, today's lesson is over distributive property. This is going to lead us into the last step of our solving multiple equations. Distributive property is dealing with parentheses, always with parentheses. You might notice the examples that I have surrounding the title. They all look like something outside of the parentheses, which we will get to in a second. If you could put this as the title of your lesson for today, and go ahead and pause the video so you can write down the 4 examples before I begin. Make sure you give yourself a little bit of space. This will take up 1 page. Okay, let's get started. So, some old things that we usually know is that parentheses should mean multiplication. Kind of like PEMDAS. Parentheses come first. P-E-M, P is parentheses. It comes first. So, take, for instance, 6 times 2 with parentheses. This is another way for us to write 6 times 2. Using parentheses tells us to multiply. 6 times 2 is 12. That's simple. Okay, what happens whenever it is 5 times something else, but not a simple number to use our multiplication facts on? What we're gonna have to do is it's basically saying that 5 is multiplied times everything inside of the parentheses. So since 5 is multiplied times everything inside the parentheses, I'm going to draw arrows, and I'm gonna have you draw arrows every time we use distributive property until I say we don't do it anymore, okay? 5 times m, and 5 times m, we write that as 5m. Because 5 times a variable we actually don't know the answer to, because this is still a missing number. It's a hidden number. We have to solve for it if we were solving equations, okay? 5 times m is 5m, and the last thing I do is 5 times 2. So I'm multiplying 5 times every piece inside of the parentheses. 5 times 2 is 10. We know that because of our multiplication facts. If you ever need the calculator to kind of just make sure that you're getting these right, use it. You have it, use it. All right, so this is technically the final answer for this right here. The reason is there's no equals something something. This is an expression. It cannot be solved. It can only be simplified. We will do one equation at the end of this video to show you what we would do further if we were solving, okay? Let's move on to this example here. We have 3 on the outside of the parentheses, and then 4 in here, and minus 2 here. That's on the inside of the parentheses. Parentheses comes first, so we use distributive property to multiply this 3 in to the 2 pieces on the inside of the parentheses. So the first arrow I drew is from 3 to 4 in. 3 times 4 in is 12 in. 3 times negative 2, I'm going to consider this a negative 2. 3 times negative 2 is negative 6. This is our final answer. Remember, we are only simplifying these. We cannot say 12 minus 6 is 6 because these are not like terms. 12 in is different because it has an in with it. It's got the variable with it. This one does not. All right. Let's go to this challenge question down here, a challenging question. Whenever we have so first of all, I see parentheses. Parentheses tell me to do whatever that says first, okay? This set of parentheses has something on the outside, as in multiplication. This is where the distributive property comes in. This is the distributive property. Draw your arrow from negative 4 to 7x. Negative 4 times 7x. We take the 2 numbers and multiply them together. 4 times 7 is 28. That equals a negative 28x. All right, the x has to stay along with it if it was there to begin with. Then we move on to negative 4 times negative 2y. Yes, this is a minus 2y, but when we're multiplying it as integers, we say that this is a negative 2. We consider it that way. Okay, so negative 4 times negative 2 is a plus 8y because 2 negatives multiplied together make a positive. And then last but not least, negative 4 times 8 is a negative 32. This is the final answer. The reason we cannot put these 2 together, like combining like terms, is they are actually not like terms. One has an x, the other has a y. They can't go together. They're not best friends. Okay. All right, and then our last example. What if you just had a negative sign or a minus sign in front of the parentheses? technically, we still have to distribute. What's happening here is there is actually an invisible 1 right there in front of the parentheses, just like it is on variables, okay? So we have a -1 multiplied times a -2x. Two negatives multiplied together make a positive. We have a positive 2x. Then we have this -1 multiplied by 13. -1 times 13 is -13. You might notice that all it did was multiplying by -1 does is change the signs. This -2x became positive 2x. This positive 13 became a -13 if we were looking at it like integers. This reads 2x minus 13, and this is our answer. We now have one example with distributive property inside of an equation. This is an equation. The reason I know is there is an equal sign. I am going to search for the missing variable, the number that this variable represents that they're not telling us. In all of these examples that I did, there was no equal sign. It is called an expression when it's that way. Whenever there's no equal sign, you are only going to simplify as much as you can. With an expression, you can actually start to solve. So, using distributive property, because I see the parentheses, I know I have to do the parentheses first. So if there was a bunch of extra stuff to this equation where it was like +2 minus 5x, things like that, I would still not worry about the rest of it and only focus on the parentheses and the distributive property. I take the 2 and multiply it into the x and into the 4. Okay, I'll do it one at a time. 2 times x is 2x. 2 times 4 is 8. I am going to put a plus in the middle of that because 8 is a positive number. I don't usually write positive 8, but I'm going to put a plus sign there just to make sure that I know that in between, I'm adding now that it's a positive. If it were a negative, I would have put a subtraction sign, okay? It still does equal 16, and now I have a two-step equation. I could draw my line if I really want to keep me organized from moving back and forth. And then I start using my inverse property to move some things around to get to like terms. Remember that I said we started with the addition and subtraction first? Now I want you to start thinking of it as a like term. So the like terms out of this equation is this 8 and this 16. These are called constants. They're numbers that do not have a variable. All right, I need to put them together. So I'm gonna go ahead and move this +8 over here to this side. The way I do that is the inverse property, so I subtract 8 on both sides. The reason I'm moving the 8 over here with the 16 is because I'm trying to get x isolated. I need x all by itself at the very end of my problem. If I start moving the 16 over here, I'm only adding things to the side where the x is. So I need to get it isolated. This will cancel out. 16 minus 8 is 8 again. And I now have this 2x on this side. One more step is to divide by 2 because right now it is 2 times x. I do the opposite. 8 divided by 2 is 4, so x equals 4.